Since the check is so vital to solving equations involving radicals, I want you to get used to using your calculator to serve as a rough check. Now, your calculator may not give you the exact answer, but should keep you from making a major mistake. If you do not have your calculator with you now, go get it, and I will show you how you can check your answers using a graphing calculator. Just use your calculator to verify the solution for the square root of 2x minus 1 plus x is equal to 8. Well, for using your calculator, the first thing you want to do is to set everything equal to 0. In other words, to put it in the calculator, we need to set everything equal to 0, which means I need to subtract 8 from both sides. So I'll subtract 8 from the left, subtract 8 from the right, and then 8 minus 8 is 0. So I now have everything set equal to 0. I do that because that's what the calculator requires for my y equals, if you remember from earlier examples with calculator. Now with the calculator, what you want to do is to set the range. So turn your calculator on, and you can go in and set the range. Now, one way you can set the range to standard is to go to your zoom function, and you can come down and set the range to standard if it's not already set. I have something in the graph, so I'm just going to go ahead and clear that, not worry about it. But now I have set the graph back to standard, and that's one way that you can do it. Now what we want to do, once we get the range, we want to graph y is equal to the square root of 2x minus 1 plus x minus 8, and note the y-intercept. So what I need to do is to get my calculator back, and I need to hit the y equals key. Now, for the y equals key, using that, I need to enter my function. Well, the function was the square root, so I'm going to hit inverse square root, so hit the square root symbol. Now hit parentheses 2x minus 1, close the parentheses, plus x minus 8. So your calculator should look like this now. Just put in the equation. Y is equal to the square root of 2x minus 1 plus x minus 8. Now be sure you put in the parentheses. Now once you have that, simply hit the graph button. And there's your graph. Now what we want to know is, when is y 0? Because remember, it's y is equal to all this, and we set it equal to 0. So what I want to know is, where is y 0? Well, y is 0 where it crosses the x-axis. So this is where y is 0. Well, what's the value of that number? Well, let's bring this little rabbit over there, and I'm leaving it on y is equal to 0. I'm bringing it over until it looks like the little rabbit is on the line. Well, notice it's somewhere between 4.8 and 5.1. Well, our solution happened to be 5, so that pretty much convinces me that we're correct, because we can't tell exactly where the rabbit crosses the line there. Now, of course, if we wanted to, we could do a zoom if we weren't sure. I can do a zoom, and I can come down and zoom in, and I can be sure of where it crosses. And let's see if we can get the rabbit lined up a little bit better. There you go. So now we do have that the answer is indeed 5. But really all we want to do is to see if we're in the neighborhood. So the graphing is a good way of checking to see if we're in the neighborhood, and then let the algebra tell us what the exact answer is. Let's solve another one for x. X to the negative 2/3 minus 1 is equal to 3. Now this is a radical equation because remember that fractional exponents can be converted to radical form. So we do have a radical equation. Since the denominator of my fractional exponent tells me the index, I know that I have the cube root. Since I have the cube root, I have an odd index. Odd indexes or odd indices produce no restrictions. So there will be no restrictions. The next step will be to isolate the radical. Now, since this part involves a fractional exponent, that part's a radical. So I need to isolate it. So that means I need to add a positive 1 to both sides. So I get x to the negative 2/3 is equal to 4 when I add a positive 1 to both sides. Now I need to get rid of that exponent negative 2/3. To get rid of the exponent negative 2/3, I need to raise it to the power of negative 3/2. So I'm going to raise both sides to the negative 3/2 power. Now what you do to one side, you've got to do to the other side. Now why the negative 3/2? Well, I want x to have an exponent of 1. To raise a power to a power, you keep the base and multiply the exponents. Well, in order to make it a positive, I needed to raise it to a negative exponent because a negative times a negative be a positive. And in order to make it 1, I needed to multiply by the reciprocal. The reciprocal of negative 2/3 is a negative 3/2. And since to raise a power to a power, you multiply the exponents, I needed to multiply by the reciprocal, so my exponent needed to be the reciprocal. Now that leaves me with x to the first power is equal to 4 to the negative 3/2. Negative times negative is positive. That would be 6/6 or 1. So I get x to the first. And I'm leaving this 4 to the negative 3/2. Now x is fine. But a negative exponent tells me to take the reciprocal of the base. So I have 1 over 4 to the 3/2. Now I'm going to change it to radical notation so I can evaluate it. So I have 1 over the square root of 4 cubed, which is going to be 1 over 8. The square root of 4 is 2. 2 cubed is 8. So I think that x is equal to 1/8 is the solution. Now let's check it with the calculator. Now these, we really do not have to check this one because we had an odd index. So the check is optional, but we're going to check it anyway.